Okay, this is lesson 1.1, solving exponential equations that are like bases. So, the first thing you have to look at is the type of exponential equations. So, our exponential equations are like this. Y equals A times B to the X. That's the basic exponential equation. What we always do is we typically are dealing with just the base number and the exponent number. That's what we're dealing with. So what we've got right now is base and exponent. So x is equal to base and exponent x. That's what we're dealing with. We're trying to get the bases to become the same, okay, because your base always belongs to the exponent. So we're trying to get our bases the same, and then we're going to be able to drop them once they're the same. That's the rule. So let's take a look at a few examples. So we can solve them graphically or algebraically. Graphically, just like we did in grade 11, what we did was we did y1, y2, let them graph, and then do an intersect. So this guy right here, if we graphed him, we would have one guy going up, the other guy going up, and we want right where they crisscross in there, okay? And the solution we're looking for is the x number, okay? So we're always looking for x. Now, if you notice up here, y1 has multiple terms in the exponent. If you've got multiple terms, you need to bracket them always. And will they bracket them for you? Not typically. They expect you to know that they need brackets. Same as the fractions. So, over on the right-hand side, you see a 2 and an x. Again, even though the 2 is a coefficient, it's considered multiple items as an exponent. So that means, again, it needs brackets. So, let's graph it real quickly. We'll go to our calculators. We'll go to y1 and y2. Okay. So, where we find our equations, we're going to go up to y equals on the top left. In y1, we're going to put 4 exponent, open bracket, x plus 5, close bracket. And then we go down to y2, and we're going to put in 64 exponent brackets 2x, close bracket. Once we get our information loaded, we have no idea what kind of window we need. So the biggest thing we do is we hit graph, and then we hit zoom 0. Zoom 0 is a fit graph. It's going to try and get it so where we can see the intersection point. From there, we can mess with our windows so we can see the part we need better. So we're going to hit graph, and as you notice, I can only see part of one equation and part of one equation here. Now exponentials are always going to cross the x or the y-axis. So that means this guy is going to go way tall before he crosses this guy. So that means I'm going to have to extend which one? Do I want to go left and right extension, or do I want to go up and down extension? Up extension, right? So that's our y maximum. So let's put our y maximum to 100. So we really don't know what we need. And then our scale, the y SCL, that's the scale. That's what you're counting by. I'm just going to go 50. That shows us less notches, okay? Less increments. All right, let's see if we can see where they touch yet. Oh, we still can't see where they touch, okay? Because they're getting closer, but we're not quite there. So we go back to our window, and now I'm going to take my y maximum. 100 didn't work, so I'm going to put 500. Okay? And then I hit the graph button again. Now we see if we can see where they touch. 500 is still not quite far enough. So we're going to go to our window again, and we're going to extend it some more. So I'm going to go to 800 and see what happens. You can go to 1,000 if you want. And then I hit graph again. So we can see they're finally going to start to intersect way up there. Okay, we're still not there. I'm going to go to 1,500. Hopefully that'll be right. And this is what you would do. You would have to sit and guess and check this stuff. So we're not quite there. So we're going to go to 2,500. Okay? Now we're going to see where they touch. 2,500, they touch way up there. Okay? So I'm going to go second trace, number 5. I want an intersect, and I enter 3 times. and it's thinking. It's going to give me x is 1 for 4096. Okay, so 1 and 4096 is where they touch. So, which answer am I looking for when I solve these questions? The x or the y? The x. Because guess what number we're always solving for? X. Okay? So it took us a long time to find the answer because we had to make our scale go up high enough. So our intersection point is 1, 4096. Our answer is 1. We will solve it algebraically coming up, and we'll prove that it's 1. All right. So if we want to solve same base equations, we need to have identical bases. And if our bases are identical, we wipe them out. They cancel. So I'm going to drop my bases here, and I'm back to a linear equation. I'm back to 3x equals 18. And I divide the 3 out. So if I divide the 3 out, we get x equals 6. So x equals 6 for that situation. We're going to do the same thing with the w. The w is identical, so we're going to cross the w off. Because the bases are identical, we're going to drop them and rewrite the equation. 5x plus 2 equals 2x minus 19. Now, we typically take x to the left, but it's okay to take x to where he's going to become positive. But typically, I do it to the left. So where's the bigger x? He's actually on the left, so that's where I'm taking it. So this guy's going to move over, so minus 2x from both sides. That's going to give me an overall 3x. My 2 is going to take off to the right, so I'm going to subtract 2 to both sides. So I'm going to get 3x equals negative 21. These are canceling on the left-hand side. The 2 cancels. On the right-hand side, 2x will cancel. That's how we make things disappear. We make a zero pair, it's called. So you make it equal to 0 so that it disappears. Now we're going to divide the 3 out. So we're going to divide by 3. And we're going to get x equals negative 7. And we can always check if our answer is true. We plug it into the top and see if the left side equals the right side. Okay? Now we're going to take a look at what if the bases are powers of each other, but they're not identical yet. Well, that's when we change our bases to the same number. So 64 will go to a base 4. So whatever the lower number is the base you want to go to. So 64 is a base 4. 4 cubed is 64. So I can make that guy go into a base 4, and that's exactly what we're going to do. So this guy's going to come down exactly as he sits, because he's already a base 4. So now I'm going to turn 64 into a base 4, being 4 cubed. The exponent that is there is now going to come down in brackets, because it must multiply by that new exponent on that 4. Our bases are identical, now we can drop them. We're going to have x plus 5 equals 6x. And we want to go to where x is bigger. Where's x bigger? On the right. So we're going to take the x from the left to the right. So this guy's moving over. We're going to subtract 1x, subtract 1x. That's going to give us 5x's equals 5. 5x equals 5. Divide the 5 out, what do we get? 1. What did we get when we graphed it? 1. Okay, so x equals 1. So we proved that when we did it and we graphed it, we got the intersection, we got the exact same answer when we did it algebraically. Often the algebraic will go much easier than having to fill with those windows. I showed you the window wave first, so that you know sometimes it takes a while to find the window that works. Okay? It will be a guess and check thing you have to work with. Okay, we're going to go through a few more examples. Okay, so I often will put an E or an M or an H or an SE beside the question. Those stand stand for easy, medium, hard, and standard of excellence. There's still hard questions that are not standard of excellence questions. Okay, so there's actually 4 levels of questions. So these ones are all considered easy. Why would they consider those easy ones? Because the bases are identical. You don't have to do much to it. All right, so bases are identical. We're going to solve 2x equals x plus 1. So now I'm going to take my 1x to the left. So this guy is going to move over, minus 1x, minus 1x. I write really big, so I'm just going to continue below. I'm going to get x equals 1. Final answer. Okay, on B, same thing. We're going to drop the bases. They're identical. So I'm going to get a 3x minus 4 equals 6x minus 1. So again, I want to take x to where it is positive. So in this case, I'm going to take the x to the bigger x. Okay, so I want to keep x positive if I can. So I'm going to subtract 3x's here, subtract 3x's over there. So now I'm going to get negative 4 equals 3x minus 1. So what am I going to do with that negative 1? It's over to the other side. You betcha. It's over to the dark side. So plus 1 to both sides. So we're going to get negative 3 equals 3x. What number am I dividing by? 3 or negative 3? 3, the one attached to the variable. So I'm dividing by a positive 3 means x equals negative 1. Okay? X equals negative 1. Just forget these guys are here. I'm just writing really big so I can see down below, that's all. Yeah.
When you write negative 3 equals 3x, could you write it the other way?
Absolutely.
Okay.
Because it's an equal sign, you can flip-flop the whole equation if you don't change anything about the equation. So this right here, I could have wrote 3x equals negative 3. Okay? And then solve it. Okay? As long as you don't change anything from either side, you can flip-flop them. Okay? That's okay. All right. Next question. Drop our 5s. X equals 11. X minus 20. Well, on this one, I'm going to take the actual 11x away, because the other guy, if I take the x, there'll be nothing left over. It'll be 0 over there. So I'm going to take the 11x's to the left. So I'm going to get a negative 11x minus 11x over here. So when I add up all of these x's, I'm going to get negative 10x equals a negative 20. Is the green hard to see from the back?
No.
No? Good. All right. I'm going to divide out a negative 10. What's my answer if I divide out negative 10? Positive 2. So we're going to get, I'll just put it up here, x equals 2. Okay? All right, there's 3 right below it. A, B, C, where it says your turn. I want you to try those 3. Okay, I'll give you a couple minutes. Push pause now and play when you're ready. Let's take a look. Okay, first question. Drop our 9s. Then we're going to bring our 2x to the left. Okay? So minus 2x minus 2x. That's going to give us a negative 1x equals 1. And then we divide out the negative 1. Okay? Negative 1, negative 1. Therefore, x equals negative 1. Now, we could have flip-flopped the equation completely. We could have said, okay, it was x equals 2x plus 1. I could flip-flop everything. I could say, okay, well, I want 2x plus 1 on the left and x on the right. That's okay. You can do that. Okay? And then you'd move this guy here, this guy there, or just move something once. Okay? Try to get into the habit of finding out which is the least amount of steps to do. Because if it's the least amount of steps, there's a better chance you won't make a mistake with less steps. Okay? So try to keep it simple. All right. So you get negative 1 for the first one. Let's check out B. So B, we drop our bases. 2x subtract 7 equals 4x subtract 1. Alright, just gotta move this over here. So x equals -1 on that guy. I'll switch to blue so we don't get confused. So I'm going to bring, well, since 4x, actually I'm going to switch some sides. Since 4x is bigger than 2x, I'm going to flip-flop the equation and put the 4x on the left. So I'm going to rewrite this with everything flip-flopped. So I'm going to go 4x minus 1 equals 2x minus 7. Now I'm going to take my 2x to the left, so I can subtract 2x, subtract 2x, take my 1 to the right, so plus 1, plus 1. That's going to give us a 2x equals -6. Okay? Then we're going to divide out the 2, divide out the 2. So x equals -3. Okay? How'd you do on the first two? Pretty good? Okay, let's check the last one. Now, I have two things on the right-hand side. This guy's got one thing, so I'm just going to bring the x to the left, and then I can solve it right away. So I'm going to subtract 1x here, and I'm going to subtract 1x here. We can drop our bases because they're the same already. So -2x and a -1x give us a -3. So we've got -3x equals -18. Okay? And now we just divide out the -3. So divide by the -3. We're going to get x equals +6. Okay? So on these medium questions, the reason it's considered a medium question is because one of them or both of them are not in the same base. So you always try to make it go down to the lowest base. So on the left-hand side, 4 can go to a base 2. So the left-hand side we don't have to change. The right-hand side we do. So I'm going to rewrite the left. And now I'm going to change 4 to a base 2. 2 squared. Then I put the expression that's already in the exponent there. It's going to go in brackets. And now you've got to multiply that 2 into the bracket. So 2 multiplied by x and the 1. We can drop our big bases. So the big bases are gone. So we've got 2x equals 2x plus 2. Now this one's unique. Because what do you notice? What's going to happen to x? It's going to cancel and disappear, isn't it? So we're going to have -2x minus 2x. We're going to have 0 equals 2. So that one has no solution. Whenever your x's cancel out, it's considered to have no solution. Okay? All right. We take a look at B. 9 and 27 will both go to base 3. They both don't go to base 9, so you can't take 27 and go to base 9. They're both going to base 3. So that means that 9 is going to go 3 squared, 27 is going 3 cubed. Now we're going to put the exponents back. X minus 4 and x minus 1. Now we can drop them big bases. Big bases are gone. Once the big bases are gone, we're going to multiply into the bracket on the left and multiply into the bracket on the right. You have to multiply, it's distributive property, so you're multiplying to both terms inside. So we're going to get 2x subtract 8 equals 3x subtract 3. Now since there's x's and digits on both sides, it really doesn't matter where you take x to. If you wanted to flip-flop the equation to keep x positive, you could. So I could put the complete left side and right side, change them up. I'm just going to do it the normal way. So I'm just going to take the 3x and move it to the left by subtracting 3x. And then I'm going to move the -8 to the right by adding 8. So add 8, add 8. Okay? Now I simplify my like terms. So I'm going to add up all the x's, and I'm going to add up all the digits. Everything else cancels. So these guys cancel, and these guys cancel. So we end up with -1x equals 5. What are we going to divide by, 5 or -1? Negative 1, the one attached to the variable. So divide out negative 1, how big is x? Good. X is negative 5. How's that going, okay? Yeah? Good. All right, the next one we see in a fraction. Now, if it's in a fraction, we have to flip it up top, because we don't want it in a fraction. So, we're going to flip this guy up. When we flip him up, he's going to become, right now he's got a hidden positive 1. He's going to become x to the 8 to the negative 1. So we've got 8 to the negative 1 equals 4 to the x minus 20. Now we're going to take 8 and the 4, and we're going to put them into base 2. Because 8 won't go to a base 4. So, we're going to base 2 them. Just going to draw my line around this stuff. So, 8 goes 2 cubed, and it's going to multiply by the negative 1 that was already there. On the right, the 4 is going to turn to 2 squared, and it's going to multiply by the x minus 20. Okay? So now your bases are the same. You're going to drop your bases, and you're going to multiply on the left to get a negative 3. And you're going to multiply into the bracket on the right. So you're going to get 2x minus 40. Okay. At this point, I'm just going to flip-flop my equation. 2x minus 40 equals negative 3. And now I'm going to take my negative 40 to the other side. You can think of it like this if you want. Take your 40 to the left. That's fine. You're going to add 40 to both sides, no matter which way you do it. So we'll get 2x equals 37. This one's going to give us a decimal answer, and that's okay. So we just need to take 37 now and cut it in half. So we are dividing by the the coefficients. So now this is going to give us x equals how big? 18.5. Good. All right, the 3 on the bottom there, A, B, C, please do those. And I'll put them up in a few minutes. Push the pause down when you're ready. Okay, the solution for your first question I have done for you. Check the steps and check all your work. Make sure you've done it correctly. The second one, we're taking to a base 11. The right-hand side is already base 11, so it doesn't need to change. So we're going to have 11 with 4x minus 3. So now we can drop the bases. Bases are identical, and we multiply into the bracket. So 2 multiplies into the x and the 1. We're going to get 2x minus 2 equals 4x minus 3. And now we're just going to, we can flip-flop our equation if you want to, or we can just take x to the left and the constant to the right. I'm just going to do it that way this time. So I'm going to take the x to the left. Both ways work, it really doesn't matter. But if you want to keep x positive, take it, the smaller x to the big x side. So minus 4x. Now I'm going to end up with a negative. It's okay though. Sometimes negatives mix people up, so try and get it right. Alright, so I've got negative 2x on the left. Now I'm going to take my negative 2 to the right. So I'm going to add 2, add 2. So now when I add my like terms on the right, I'm going to get a negative 1. And now I'm just going to divide out with my coefficients with negative 2. So we're going to get x equals 0.5. Just put 1/2 fraction if you like. 0.5 is an exact decimal, so you're allowed to use the decimal. If it's a repeating number or a run-on number, just use the fraction, please, okay? All right, so now we're going to get into the hard standard exponent stuff. So here's the harder stuff. Oh, we didn't do C. I only did the first 2.
Is there a
Not
decimal
C.
for C?
Okay, we need to do C still. Do you need a couple minutes to finish it?
Yeah.
Yeah? Okay. Okay, let's go. Okay, when we look up here, the very first thing you need to do is flip that 5 with the exponent 8x upstairs. So when this guy flips up, that 8 is going to become a negative 8x. So we're going to have 5 to the negative 8x equals 5 squared. That's what 25 is, 5 squared. Now I open a bracket and put this exponent that's there, x minus 8.
Why does a 5 not become a negative when it's switched?
Because he's on the bottom of a fraction.
Oh.
So remember whenever we've got something like this, 1 over 3,
Yeah.
and if I flip him up, right now he's got a positive 1 exponent, he's going to become 3 to the negative 1. Okay? So it's always these exponents are going to flip and become the opposite sign. Okay? Always. Yep.
So then if the exponent wasn't there, then it just the 3 would be negative.
No, not the 3. There's always, if you don't see the exponent, it's always a 1.
So say like if it's just 1 over 3 and you flip it, it'd be negative 3 over 1.
No. No. 3 to the negative 1. The negative sign does not go to the base. So you're not going to put a negative sign here. Never, ever, ever. The negative goes to the exponent. Always, always. Okay? Alright. That's just something we have to remember. Okay. So, now that we've got our same bases, we can drop our base. So, dropping base. Now we get negative 8x. We're going to multiply the 2 into the bracket. Don't forget you have to multiply to both terms inside. So you're going to get 2x minus 16. Now you need to take the x's to the left. So, 2x. What's that?
No, that's why I got it wrong. I figured it out.
Okay. I'm glad you figured out where you need the straight. So, minus 2x, take it across the equal sign, minus 2x. This is going to give us a negative 10 x's. So we're going to get negative 10x equals negative 16. Now we're going to divide out the negative 10. Basically all it does is give us a decimal point. So dividing out negative 10, x equals positive 1.6. Okay? So that's what we're going to get for those. Okay, so you have to take it step by step by step. Okay, slow it down. All right, let's tackle these last 6. So the medium and the hard. We're going to go through all 6 of them together, okay? So I know some of you are starting on these ones, good for you, and some of you are doing very well. Let's check and see our work. So, who has to switch on that first equation? The 27. Okay, so what you do is you check both numbers, and you see if the big one can become a power of the small one. So if I find any number, 3 exponents something gives me 27, yep, there is a number, 3 exponent 3. So I've got 3 to the 3x minus 1 on the right, or plus 1, pardon me. On the left-hand side, it doesn't change. The right-hand side, 27 is going to become 3 cubed, and it's going to multiply to that 2x. It's already sitting there. So now we're going to drop our base, and we're going to get 3x plus 1 equals 6 x's. Okay, so what do we do now? We can flip-flop it or move x to the left, move the 1 to the right. I'm going to flip-flop it so we don't have to move so many things. So I'm going to go 6x equals 3x plus 1. And then now I'm going to move my 3x to the left. So I'm going to minus 3x, minus 3x. So that's going to give us 3x equals 1. Now I'm going to divide out which number, the 1 or the 3? The 3, good. So our answer will be 1/3. So x equals 1/3.
Could you change that to 0.3?
Because it's a repeating number, no, you'll leave it as a fraction. Now, if it was a numeric response question, they'll tell you how many digits they want you to round. Okay? So if they said hundredth, you'd have 0.33. Okay? Any questions so far on the first one? If you try the question, who got it right? Nice work, you guys. Good job. Who didn't get a chance to try it yet? Good, that's okay. All right. Let's take a look at the next few. Are we done writing it down? Am I allowed to erase it yet? Yeah? Okay, it's gone. Okay. These both go to base 3. 3 squared, 3 cubed. Now we're going to put the bracket of the exponent that's already there. So he's going to times by 5x This guy's going to times by 2x plus 1. Now we drop our big bases again. Okay? The big bases are gone. So, multiplying the bracket, I'm going to have a 10x equals, multiply both. Okay, the 3 on the outside, the coefficient is distributive property, we have to multiply in the bracket. So we're going to get 6x plus 3. Okay, when I went around, a lot of people had 1 there. They forgot to multiply the 1, so don't forget that guy. He's lonely. He needs to be multiplied. All right. Now we're taking x to the left. So we're going to subtract 6x to both sides. Okay? Now I'm going to get 4x equals 3. 4x equals 3. Final step, you're going to divide out the 4. So divide by 4. X equals 3/4. This is an exact decimal, so you could use 0.75. Okay? Are the steps looking okay? Yeah? Okay, make sure you have the steps written down, please. And we'll move on to letter C. What you've got to notice with letter C is that there's an exponent only on one side. If there's an exponent only on one side, and the base number has a coefficient like this 10, you're able to divide it out. And the reason you're able to divide it out is because the right-hand side does not have an exponent. That's why you're able to do it. So, I'm just going to erase this stuff for us, and we're going to start. So, first step, divide the 10 out. Get rid of that 10. That gives us 27, which will go to a base 3. So 27 now becomes 3 cubed. Okay? So when 27 becomes 3 cubed, look at that, 3 cubed, and that's what I'm going to write below. So we've got 3 to the x plus 1 equals 3 cubed. So it looks like a nasty question, but really it's a lot easier and shorter than some of the others where you have x on both sides.
So what's that time you would take the 3 out of the brackets?
Yeah. All right. So now drop our base, and we've got x plus 1 equals 3. And just by looking at it, hopefully we all know that the answer is 2. 2 plus 1 is 3. But if we want to show our work, we're going to subtract 1 to this side and get x equals 2. Okay? Letter D and E are considered hard questions. F, I want you to write SE beside it because letter F is a standard of excellence question. We will do E and F now. May I move it up? Not quite? I know. Real fun. Okay, the 4. The 4 is going to become 2 squared. So I'm going to write 2 squared instead of 4. Okay. Now I need to flip that guy up top. When I flip it up top, what's going to happen to the exponent? It becomes negative. So, left-hand side, 2 to the x minus 2. Right-hand side, 2 to the negative 2 is what this becomes. Then I put a bracket to multiply into the exponent. Now I can drop my base. So my bases are identical. They're gone. I'm going to get x subtract 2 on the left. On the right, I need to multiply that negative 2 outside to both terms inside. So we're going to get negative 4x minus 2. Okay? Now we're going to take our x's to the left. So negative 4x is going to add 4x. We're going to add 4x here. Then we're going to move our negative 2 to the right. We get positive 2, positive 2. And we cancel what disappeared on each side. So those 2's disappeared and the x's disappeared. Now we add like terms on both sides. So I'm going to get x and 4x give me 5 x's. 2 and negative 2 give me 0. So now, if I divide 0 So if I have to divide out by the 5, right? So I want the x by itself. So I do need to divide it out. But 0 divided by anything equals 0. So the answer for this guy, x equals 0. Okay?
Does that mean anything? Or
No, it's just x equals 0 in that case. So that means on the graph, where do they touch? Right in the middle. Okay, x was 0. All right, what do you notice about letter E? It's similar to letter C. How come? Because there's only an exponent on one side. We like the ones with the exponent on one side because they're way easier. All we've got to divide out now is the 2. So we're going to divide out this 2 from both sides. Am I allowed to erase all that one left there? Yeah, if you're not done writing it down, you'll have to get it from a bite. I'll give you my answer if you do that. I just don't want to confuse you with stuff right beside it. Alright, so this 1/2 on the right-hand side, the 2 has a positive 1 on it. I'm going to flip that 2 upstairs. What's going to happen to his exponent? It becomes -1. So, the 2 is gone here. We divided it out. The 4 is going to become 2 squared. On the right-hand side, we get 2 to the -1 when we flip it upstairs. This guy flips up. Okay? Now, we're going to put the exponent on the left. The exponent was 2x plus 3. So now we've got our bases. They're identical. We're going to drop our bases. And then we're going to multiply into the bracket to get rid of the brackets. So we're going to get 4x plus 6 equals -1. Now we need to get x by himself to isolate. So that means the 6 has to disappear and go to the other side. So how do I get 6 to move over? Subtract 6. Good. So we're going to subtract 6 to both sides. It disappears on the left. So now we've got 4x equals -7. This answer will be a fraction. So we have to divide out the 4. We're going to get x equals -7 over 4. Is it an exact decimal?
Yeah, it's nice.
-1.75? Okay. So it's an exact decimal, so you can use the decimal answer for sure.
So when we put a decimal,
Yes, if it's a run-on decimal or a repeating decimal, leave it as a fraction. Because in that case, Ryder, what they might do is they might say, okay, here's your fraction, and they might say, what is the bottom number of your fraction? What's the denominator? And then you put 4 in the numeric response box. Okay, that's one situation where you can see something like that. Now we're going to tackle a nasty one. All right, it's not as nasty as it looks, actually. There's a power law we have to do, though. So what happens with this power law? So take a look. I'm just going to do an example. 3 to the 4th divided by 3 squared. What would I do to those exponents? I would subtract them. Well, that's what we've got to do here. Is we're going to subtract all those exponents. But we can't subtract them until we change our 9 into a base 3. So the 9 is going to become 3 squared. So I'm just going to erase everything else here on the left for us. So this is going to become 3 to the m minus 6, all on top of 3 squared times 5m minus 1 equals 3 to the 4th times m. So we've got everything in its natural form, same base. Now what we do is we're going to subtract exponents. So we can't subtract them until we multiply in the bottom one first. So the bottom one is going to become 10m subtract 2. That's the exponent it becomes. So now, we write the base once, and then we're going to subtract exponents. So we're going to have a big base of 3. Okay. Then we're going to have the m minus 6 on top, subtracting this 10m minus 2. But because there's more than one term, it has to go in brackets always. 10m minus 2. And the reason it has to go in brackets is because this subtract sign, it's actually a -1 now, it's going to multiply in the bracket, and that 2 will become positive. So that's super important. That's why we have to have that negative there. Okay, when we subtract exponents, if there's more than one term, have to be in brackets. Okay, no other reason. It has to be in brackets because there's multiple terms. Okay? Alright, so we actually do multiply that in the bracket. It's still equal to 3 to the 4m. Okay? Now that we've got it at this point, we have identical bases. We can drop those big bases. So those guys are gone. And now we just have to multiply this guy in and add like terms. So this guy is going to become -10m plus 2. So now we add the m's together to give us -9m's. And we add the coefficients, but the constants together. -6 plus 2 gives us a -4. And it all equals what's on the right-hand side, 4m. Okay? So, we multiplied the negative sign in the brackets. Okay, that's how I got my -10 and +2. Then we had to add them with the other exponent on the left. Okay? So we had to add the m's, that's why they're circled in red. Then we had to add the constants, which are circled in black. Okay? So our simplified form is what we get here as our equation on the bottom. Now we need to solve for the letter m. So I'm going to move the 9m over. So we're going to have plus 9m plus 9m. So how many m's do I get all together now? 13. Good. So I have -4 equals 13m. And if you like to switch them, you can. 13m equals -4. And now just divide out your 13. Again, it's going to be a fraction. So we're going to have divided out 13, divide out 13. So m equals -4 over 13. So a lot of steps to get to that answer. Okay? This concludes lesson 1.1 on solving the same ratio. Exponential.